In this quick tutorial, we're going to look at some of the issues that can arise when you import vector data from a third party. So the main issue that we're going to find here is that there's not a well-matched file exchange format that deals with all of the vector geometry types that the software can support, and so inevitably we have to make some modifications to the data as it's imported or exported from the software. We're going to focus on the DXF for the main parts of the demonstration, but let's start by looking at the formats that are available and just quickly run through what the limitations are in each one. So I'm going to use the File menu here and just go straight to Open, and by default on our Open menu, as well as the software's own file format, there are the major vector formats too. So there's DXF and DWG, which are the standard CAD file formats, and we're going to focus, as I say, on the DXF in a minute and talk about the specifics there. And then there's EPS and AI, which are more from the artistic packages, so that's encapsulated PostScript and the Adobe Illustrator file formats. So they tend to deal with sort of curves and loops and things more effectively than the CAD software, but they're also proprietary formats from particularly the Adobe Illustrator formats, which are not open and therefore difficult to maintain. The final one we support is the PDF file, but it's very important to note that this file format obviously is a printing file format that supports lots of aspects to do with printing, which the software is not interested in, our software is not interested in, and it also has potentially got bitmap files in it, and at the moment the software will not import any bitmap files. So if you find a PDF file which has got both vector and bitmap data in it, we will only extract the vector data from that file. So it's important to note that. Also, the PDF file, when you look at it in its printable form, so the form that's showed to you in your PDF reader, such as Adobe Acrobat, that will include lots of information that is specific to printing, like gradients, fills, line thicknesses, which our software is totally disinterested in, because we have no use for those aspects of the geometry. So you will just get raw vector data out of a PDF file, and you should be aware that that's to be expected. Okay, so those are the main file formats. We're going to focus now on looking at a DXF file that's imported through this route. So I'm going to use the imported vectors demo file here from the tutorials folder. So having opened this file with no existing vectoric file open, we get the job setup dialog initially to add in the extra bits of information that we're going to need about our job. So the vector geometry, as you can see, is imported here, but what we need to do is also put a job size material block around it. And now by default the software has made the material block exactly fit the external boundaries of this data. So the vector geometry is in exactly the same location as it was in the file. So there's nothing's changed here in terms of world coordinates. But in order to keep the job very tightly bound around the bounding box of the geometry, we've displaced the job slightly from the 0, 0 position here. So this is the 0, 0 position in your sort of main coordinate space, and then the job itself starts up here at an offset of 0.6 in X and 2.1 in Y, so just sort of half an inch and 2 inches up. But this essentially is the point which matches the bottom left bounding box of the geometry that we've just imported. Now we don't have to keep the geometry in this location. In fact, we can turn that offset off, but be aware that this will now move the position of that geometry from the world positions that it was originally in when saved in the file, and it bumps it back down to 0, 0 here. So now we have an origin based on 0, 0. We don't have to accept the job size. We can change the job size here to anything we like. So we can take the default widths which were found directly from the bounding box of the geometry and make that 12, for example. Now you can see here with the bottom left coordinate set, the extra 2 and a bit inches of material have been added to the top and the right. So in other words, they've been added relative to this bottom left coordinate, so this is kept the same, and any extra material we add in the job size X and Y is added above and to the right. We can modify how we add that material, in fact, by just changing where we stick the origin. So if we have the origin or the datum position in the middle of the block and we were to extend again, we would find that it's going to add the dimensions evenly as a border around our image. So having added the border around the image like that, we can always go back and set the datum position. So effectively the datum position can be used temporarily while you're in this form to decide where you want to add the extra material. With the datum at the bottom left, extra material size will be added above and to the right. If it's in the middle, it'll be added evenly all around the edge. If you set it to the top right, for example, then the extra material will be added down in the bottom left. So that's fine. So that's our data imported, and we can go ahead now and start working on it. So that's how we open a DXF file directly using the file open method. Now let's go on and look at some of the other ways that we could bring this data in. The other most common way that you're going to import data will be into an existing software model. So in this case, we're going to create a new file to start with, which will make 12 inches square here. So we've got a blank new model, and we can use the option up here to import vectors from a file. We can also import them using the file menu, import vectors here. And if we use this method, we can choose the same file we had in the initial discussion, but bring the data into our already sized job, as you can see, and the positions of the items are maintained, but this time we've created the job size ourselves rather than have the software work out a minimum bounding region. So that can be very useful if you want to bring in material that of designs that you've created that are correctly located already relative to the job that you're already working on. When you import those vectors through this method, their positions will be maintained and they will be brought in just into the job as you've already created it. Be aware though, what I'm going to do now is bring in another example. So we'll use the menu method this time, sorry, the button method this time. I'm going to bring in this imported vectors 2, and when I import that, apparently nothing has happened. Now this is the first of the sort of gotchas to watch out for. It has actually worked, and if I zoom right out from my job, I can see that up here in the far right hand corner is my imported second file. And the reason that it's imported up there is it has done exactly the same thing as the first file import. It's maintained the original position of the vector geometry as it was saved. So be aware that sometimes when you receive files from third parties, you don't really know the exact position of that geometry in real units, and so it may well be way off your initial design if you try and import it through this route where you've laid out the design first. Obviously, if we imported this file directly through the method first discussed, then the software would automatically find the bounding box, it would offset the material block to exactly match, and you would definitely see the file that you just imported, albeit that it would have a massive offset in real units to the origin of the material block to start with. So that's the first gotcha to watch out for. Now let's have a look at the layers that have come in this case. So if I go across the layers tab, one thing about DXF files is that they do preserve the layer structure of the files that were saved, and there's a couple of things to highlight here. The first is that the layers may or may not have contents on them, and in fact often if you get third-party files there'll be many layers, and many of those layers will be empty. Now the software does highlight to you empty layers, so if you look at the layer list, the little icon here not only shows you which is the currently active layer in bold and fully coloured, but these faded little icons here also show you whether the layer has content. So only the layers that show the square and circle icon here are layers with content on. These two are empty layers and we can safely delete them, and this can really simplify the process once you've brought in lots of files. Now the way to delete a lot of layers is to use the visibility first to effectively highlight which ones you're interested in. So I'm going to turn off the visibility of the ones we're going to keep so that only the layers that we're about to delete are left highlighted. Obviously they've got no content, so I can't see anything in the 2D view, but crucially I can now right click anywhere on here and have merge visible. So the merge visible command does, as you would expect from the name, it will take all of the visible layers and collapse them into one layer. So I can merge the visible layers like so, and now I have just one layer which is still empty and has no content on, and I can just delete that. And by this route I've deleted all of the empty layers, and that could be many. Now you'll notice that the layers, just as an aside, the layers list is highlighting default as red. Now the reason it's come up red here is because it's the active layer, it's the layer on which new geometry will be drawn, but it's not visible, and that's usually an error. So it's usually where if you're drawing to a layer that you can't see, that's generally a mistake. So you're prompted to note that with the colour red, and as soon as I turn the layer on and make it visible, everything's good. We now know that we're drawing to a layer that we can actually see. Okay, and then another thing to highlight just while we're on the topic of layers is you'll see that the two of the layers here, if I turn on the red and the white layers, two of the layers have got color names, and that's because the original files were saved with the layers of that color. So you can see that we've successfully brought in the layer that's red, and it is indeed red in the imported file once it's in the software. However, the white one seems to have come in black. So it's worth noting why that is. Essentially, one of the filters that we apply to the imported DXF is to pick out white layers, and actually we actively convert those to be black. And the reason is simple, that if I take this layer and make it white deliberately, which you can do in the software, you'll see that now when it's not selected, it's extremely difficult over the white material block to see this layer at all. So it's apparently invisible. And so to avoid that really common hazard, white layers that are imported will be made black. You can, as I've just demonstrated, make them white again if you so wish, but at least you'll be aware of what's going on. Okay, so that's the basics of importing using the two methods that we've just described to either open the vector directly or to import it using the vector import button on the file operations toolbar here, or the file import vectors option to give you two slightly different routes in which preserve different aspects of the geometry's position relative to your model. There is a final way of doing it, which is really quite cool as well. So you'll remember that when we originally imported this demo2, which is the Snow White tag here, I've managed to drag a little bit of the red. Let's just get rid of that distraction. So we originally imported this Snow White tag from the DXF2 vector demo 2 file, and it came in way off in its original coordinate system. So that was quite inconvenient. Another route to import vectors with a file open is simply to drag the file out of Explorer or off your Windows desktop and just drop it in the file. And the benefit of this route is it will appear where you drop it. So regardless of whether or not the original vector was positioned way off, using the drag and drop method, you can make sure that you bring the file in at the location that you're interested. So this slightly different approach of drag and drop is really handy if you're using your vectors really as pieces of clip art, which are going to be moved and positioned according to your design, rather than, for example, a piece of CAD data where you're absolutely wanting to machine it in the exact coordinate system that it was saved in. Okay, so that is a summary of the three main ways of importing vectors. Next, we're going to look at some of the hazards that can occur with the data itself once it's been imported. Okay, so for the final part of this demo, we're going to look now at the data itself once it's been imported, having gone through the importing process. So everything looks perfect here, but I want to highlight some really common issues that can arise, particularly with data that's been generated from third-party software. Now, the first thing we need to start worrying about is that often we're going to want to select these things immediately and start machining them. And that seems like a good idea, except we are going to encounter some problems straight away with this data. And one of the first things we're going to discover is, as I select these 4 circles, which we might use for drill holes, for example, you might see something odd about the top left one here, which is that it looks solid even though I've selected it. So I've selected this one goes to dotted, this one goes to dotted, and this one does not. And when I zoom in a little bit, you can see that what we've got is the normal selection color, the magenta selection color, over the top of a black color. And that's a really common and first indicator that we've got duplicate vectors. So what's happened here is we've got 2 circles that exactly overlie one another. And so when I select it, we're seeing the selected one in magenta dotted line over the top of the underlying exact duplicate, which is still black and selected. If I was to box select these, then in fact we wouldn't notice that because they both become selected, and this now becomes a problem when I pass these vectors in to say do a pocket or indeed any of the main toolpaths that are looking for bounded regions, because this region here is going to be invalid. The 2 duplicate vectors make it impossible for us to determine what's inside and outside of this shape. So we need to find duplicate vectors. That's the first issue that we'll come across. And as I say, you can spot them manually when you do a single click selection like that, but there is a much more efficient way, which is to simply go to Edit, select all duplicate vectors, and this is a really good thing to do after you've imported data from a third-party source. And you can see, in fact, not only is this one a duplicate, but here we've got highlighted 2 magenta additional pocketing boundaries as well down here. So with them all selected, I can simply click delete and they will go away and there's no more duplicates. Okay, so that's an initial really good test, duplicate vectors. Now let's look at this nice boundary rectangle that we might want to select, and when I click on it, it's not what it appears. And again, this is a really common issue, which is that many different CAD drawing packages in particular don't really have the concept of closed boundaries being a single entity in the same way that our software does. So although this to you and I looks like a rectangle, it is in fact simply 4 line segments, okay, that happen to be coincident in their line start and end points. Now often the software will correct this problem, so if in your vector geometry that you brought in we detect that there are line segments which have common start and end points and which follow each other sequentially in the file structure, then we make the usually safe guess that the data is intended to be a contiguous or continuous closed line, and so the software will often correct these and you won't even notice the error. But in this case I've deliberately contrived it so that we fail to find these because they weren't continuous in the file definition, and so we've imported these line segments. So that's another common problem, is that what you've got here is 4 open vectors and not 1 closed vector. So if you get an error message when you try and machine something like this, which says that it's detected open vectors, this is the thing to look out for. And the way to correct this one is to simply select the elements which you wish were closed or intended to be closed, and then there's several routes to this. You can use the join vectors on the toolbar here on the drawing tab, and that will simply close them according to a tolerance, and you can click join and now these vectors will become a single joined entity. There are also some other options. If I do that operation with Control Z so that we're back to our unconnected vectors, we can select them and use various options in the right click menu as well. So I'm going to right click on them now and we get the join close vectors options, and we can join them with a line, with a smooth curve, or by moving the endpoints and do them a couple at a time. So it depends really what you want to do. Typically because these are going to be a continuous vector with very, very closely overlapping start and end points, the button on the drawing tab will be the fastest way to do all of these, like so. Okay, so that's now a single vector that we could machine quite happily. Okay, so the final thing I want to point out as well is that many file formats don't support the curves that we use, the Bezier curve type that we use. So in our software it would be trivial to draw a sweeping little curve like this using a single segment, geometry segment, with the control handles that generate the curve in it. But in fact this has come from a DXF file, and the DXF file format does not support Bezier curves. So when I look at this by pressing N to go to the node editing mode, so I could use either the node editing option here on the drawing toolbar, or I can just do N to toggle to the node editing mode. Here we can see that in fact this line has come in as a series of tiny arc segments. So arcs are supported in the DXF file format, and so this has come in as a series of arcs. Now that doesn't look very efficient, and it's likely to cause some problems on your machine, and you are, for example, likely to find many things that look like smooth curves. When you look at them closer, they're going to be lots and lots of short line segments, or in this case very short arc segments. So another thing to be aware of that's a really useful and common tool is to vector fit these. So we can take our selection here and we can fit curves to it, and we can make them Bezier curves, and we can simply preview what we're going to do there. That looks a lot neater. So that's now going to just use only 2 or 3 segments for each curve, and we can click OK to accept that change. Okay, so now we've got very little variation from the original code of the original imported vector, but you can see that we've got way less points, and we'll generally get a much better machining result from that. So be aware that the DXF file in particular is not likely to give you good smooth curves when you import it. It's likely to be line segments or small arc segments for a sweeping curve like that. Okay, so that's essentially the main hazards to look out for. So I hope that helps you solve any issues you might have when importing particularly DXF type files.